Hello, and welcome to our webinar on pool chemistry. This webinar is one of our several from our Enhance Your Expertise series. My name is Shrey Prajapati, and I am the Manager of Marketing and Product Management at SensorX. These webinars are meant to give you a strong foundation in 5 quick minutes. Here are the topics we will be covering in this short time. We will start with why it is so important to monitor water quality, the challenges you may face. I will then give you a baseline in pool chemistry, and then we will discuss how to monitor pH and chlorine. So let's get started. Is having a clean and inviting pool important to you? How about making sure swimmers don't get skin irritation? What about having equipment and instrumentation that lasts a long time and doesn't corrode so easily? All of this can be achieved through proper water monitoring and treatment. So why is striking the right pool chemistry so challenging? Well, for starters, swimmers bring with them oils, sweat, dirt, sunscreen, and so much more. This becomes even more complicated when you don't know how many swimmers you will have on any given day. Pretty soon, your pool could end up looking like this. There are 3 types of contaminants in such a pool: physical contaminants, which are typically dirt and debris; chemical contaminants, which are from cosmetics, lotions, and sweat; and then finally, organic contaminants, which are microorganisms like bacteria and viruses. You can take preventative measures by installing mechanical filtration that will remove the dirt and debris. You should also treat it with chlorine, which oxidizes the impurities and destroys pathogens. We are going to explore chlorine a lot more here. Before we dive into chlorine, though, we have to revisit the basics, and that starts with pH. pH is the indicated relative acidity or basicity of a liquid. Water typically has a pH of 7, whereas vinegar has a pH of 3. On the opposite side of the spectrum, soap has a pH of 12. Without diving too deep into how pH is calculated, what you must understand is that it is dependent on the concentration of hydrogen ions. Let's talk about chlorine. It's the 17th element in the periodic table. It is one of the halogens. It is commonly used in household cleaners and also for sterilizing and disinfecting water. Why did I bring up pH? Well, it's because pH and chlorine are linked. Chlorine used for disinfection exists as hypochlorous acid. To simplify, I'm showing the scale between 8.5 and 6. So as pH decreases, the effectiveness of chlorine disinfectant increases. But we have to be careful. pH of 8 or more shows bad disinfection. It can also cause eye and skin irritation. Too low of pH, below 7, could cause pipe corrosion and also eye and skin irritation. Therefore, chlorine levels must be maintained between 1 and 3 ppm while maintaining pH between 7 and 8. How do you monitor pH and chlorine? Are there test kits available? Yeah, sure there are, but those are spot checks. Recall how I said you can have fluctuations in the number of users? You can potentially have a whole lot of people with skin irritation and issues before spot check is conducted, and by then it may be too late. To avoid this, you must do continuous monitoring. SensorX's pH 5000 and ORP 2000 are 2 examples of sensors you can use for monitoring. You must purchase a transmitter with it so that it can read and display the values. Well, now you must be wondering why ORP. Interestingly enough, ORP increases logarithmically with the hypochlorous concentration. In fact, the effect of it is so strong that it masks the effect of hypochlorite and chloramines, which typically interfere with chlorine readings in those test kits. This gives inaccurate measurements. Using ORP for chlorine is also a popular option in Europe. You could also purchase a free chlorine sensor and an accompanying pH sensor. SensorX has smart sensors where electronics are embedded in the sensor that can interpret raw readings and convert them into digital signals that can be displayed on a PLC. This is a much more robust solution. If you're looking for a more cost-effective solution, you can opt for a more robust ORP sensor with the digital communication and get all the features and benefits that come along with it. If you have any questions about how our products can help you solve your pool chemistry issues, please speak to our customer service. Their info is shown here. Be sure to tell us if you have a chlorine or saltwater pool, as this may change our recommendations to you. I hope you enjoyed our new webinar segment on pool chemistry. Thank you for listening.